Welcome to the deep dive. Today we are tackling something that's pretty dense but really critical in the world of networking hardware.
We are.
It's the Aurora IP-24PoE-Plus injector. And our mission really is to get to the bottom of why this device is such a huge deal for anyone doing system integration.
Right, because it feels like this is the moment where high-speed data, we're talking 10 gigabit, finally got properly merged with high-power delivery for, all those demanding devices out there.
Exactly. I mean, the whole story around this thing is that it solves this massive problem in modern AV installations. You have these high bandwidth devices, especially 10G video systems, that are just so power hungry.
Yeah, they need a lot of juice.
And the network switches just can't keep up. They run out of power, and then you're stuck using all these messy, unreliable little power bricks everywhere. So, okay, let's unpack that.
Well, what's really fascinating when you look at it is just the sheer capability they've managed to pack into a single unit.
Mm-hmm.
We're looking at 24 RJ45 ports, and they support both the standard 1 gig and, crucially, the high-speed 10 gigabit data rates.
And that combination is really the key, isn't it? The speed and the power.
It is. And when you dive into the power metrics, it's designed to deliver up to 30 watts for every single port. That's what puts it in that PoE plus or PoH plus category.
Okay, so it's fully compliant with the IEE 802.3 adder and Nestor.
Exactly. And that 30 watts is basically the minimum you need for these powerful 10G devices that are becoming more and more common.
Let's talk about the density for a second, though. You've got 24 ports, all pushing 30 watts. That adds up to a massive 750 watts of total available power.
A full 750 watts.
And it's all packed into a chassis that's only 1 RU, just one single rack unit. I mean, that sounds like a serious engineering challenge just in terms of heat.
Oh, it absolutely is. I mean, handling that much power in such a small space, it needs some very specialized thermal design. The sources say that was a core focus. But the reason for that density, it ties right back to its main purpose. This injector was built specifically for Aurora's IPX series SDVoE AV-over-IP product line.
For listeners who might not be familiar, what is SDVoE?
So SDVoE stands for Software Defined Video over Ethernet. It's basically the standard for sending uncompressed, super high-def video over a network, and that needs that huge 10G bandwidth.
Got it.
So this injector lets those high-power devices, the PDs or power devices, get all the electricity they need right over the Ethernet cable. No more local power supplies. It completely gets rid of that whole wall wart headache.
And it's pretty versatile too, right? It's not just locked into that one system.
Not at all.
The sources confirm it can also power HDBae PoH products. So for anyone listening, can you just quickly break down the difference between PoH Plus and PoE Plus?
Sure. PoH plus R, or power over HDBae, is just the industry standard for sending power alongside HDBae signals, which is another big method for AV distribution. By supporting both, this injector becomes, kind of universal fix.
Yeah, a universal solution for all kinds of AV hardware.
Pretty much.
I think the most interesting use case, though, is as a power booster. Like, if I have an older 1G PoE switch that taps out at maybe 300 watts total, I could use this injector to basically upgrade its power without having to rip and replace my whole setup.
Precisely. It lets you get the most out of the gear you already have. And from a logistics point of view, it's TAA compliant and tariff-free.
Which is a big deal for government or institutional jobs, that TAA compliance means it meets certain sourcing rules, which usually points to high reliability.
Right.
So I think the knowledge nugget here is pretty clear. This little 1RU box is the answer to a growing physics problem in 10G AV. It just neatly combines the speed you need with the power you need, all while keeping your installations clean and, frankly, sane.
Which really raises an important question for you to think about. If 10G power delivery is now getting standardized in these compact injectors at 30 watts a port, what happens next? What happens when new devices come along that need 60 watts or even more?
Right. How long until we hit the physical limits of our current copper cabling?
Exactly. How quickly will that push the industry to adopt the next generation of power over Ethernet standards? Something to mull over until our next deep dive.